Good morning. Welcome back to day 3 of your student-paced learning experience involving the forms of energy. So far, you should have learned what energy is. You should know the similarities and differences between potential and kinetic energy. In today's lesson, you will be taking notes over the 4 types of potential energy. Those 4 types are as follows: gravitational, elastic, nuclear, and chemical. So thus far, you should have completed in your Freyer model notes yesterday the PhET simulation over the energy skate park. I hope that you understand the law of conservation of energy states that energy cannot be created or destroyed. Energy is only transferred or transformed within a system. So as we move from potential energy to kinetic and from kinetic back to potential, those totals must sum or add up to 100% of the total energy available. So today, let's embark on our next voyage. You should have in your energy packet some Freyer model notes. They will follow in this order for potential energy. Again, gravitational, elastic, nuclear, and chemical. You will need to define what that form of energy is in the upper left-hand quadrant. Then you will need to draw 2 examples. Make sure it is your best work. And any extra information we give you should go in the bottom right-hand quadrant. So let's talk about the first form of energy that we're going to cover. The first form is gravitational potential energy. You will find the video that you're listening to right here. So as you go through the Genially, always look for the play button for one of your teacher's lessons. And any questions we have over here should spark your interest, and that is what you should be learning about that form of energy. So I'm going to ask you right now, gravity is affected by what 2 factors? If you remember from the last unit, you probably already know, but we will be hitting that again. Also, you should know if you weigh 100 pounds on Earth, you'd weigh something totally different based on the different planet that you would be on. That's a little food for thought. So here is our first lesson. Gravitational potential energy is stored energy by objects due to their position or height above Earth's surface. So gravity depends on these 2 factors, the mass and height above the ground. The bigger they are, the harder they fall. That's not just a saying. It's actually true. Objects with more mass have greater gravitational potential energy. The formula to calculate gravitational potential energy is mass times gravity times height. Over here you will find a nice picture that demonstrates the force of attraction between all objects. That force of attraction is called gravitational energy. So here's an example of your Freyer model notes. As you'll notice, the first one we have done for you, but we will slowly start putting less and less information on these Freyer models, and it is your responsibility to take notes from the slides and do more research. So in the upper left-hand quadrant, the definition of gravitational potential energy is: gravity is the force of attraction between objects based on their mass and distance. So when I say gravity, you say mass and distance. Are you ready? Gravity. 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 So, gravitational potential energy is the potential energy stored in an object based on its mass and height off the ground. Objects with more mass should have more gravitational potential energy. Objects that are higher off the ground will have more gravitational potential energy. Look at the example I have placed on the upper right-hand quadrant. You will notice this is a roller coaster. At point W, this is the highest position off the ground, so therefore we would have the most gravitational potential energy. Where do you think we will have the least amount of potential energy? If you picked point X, you are correct. X is the lowest point on the graph, therefore it would have the least amount of gravitational potential energy. What about point Y? Point Y will have gravitational potential energy, but not as much as point W because it's not as high off the ground. Here's another example. There is a boulder on the edge of the cliff. It is not moving, but it has stored energy due to its position and its mass. The boulder obviously has mass and it's off the ground, so it has stored gravitational potential energy. Please pause the video now and fill out your first Freyr model note.